So you recall that chapter 2 was about atoms. Where are we here? Atoms, right? And chapter 3, you might imagine, is going to be the next step. So what would the next step be in our conversation about the study of materials? Recall that in order to understand materials, we are going to work to understand the behavior of atoms and molecules. And so, yes, you guessed it. Chapter 3 is going to be about molecules. So let's start out with a reminder of the definition of atoms and molecules. First of all, atoms, according to page 3 intro, are submicroscopic particles that constitute the fundamental building blocks of ordinary matter. All right, we know there's such thing as subatomic particles, but submicroscopic particles that constitute the fundamental building blocks of ordinary matter. And then molecules are specific geometric arrangements of atoms that are bonded together. Specific geometric arrangements of atoms that are bonded together. Okay? So water is made up of, and the example that Tro uses is water, and let's go to that now. Water, these are all little references, by the way, so they're too small to see in your video, but 2016 gets a copyright. Pearson made that for their text. Water is made up of hydrogen. Let me get my pen back here. Hydrogen and oxygen. Hi, Michael. Are made up of hydrogen and oxygen molecules, right? So, rather, hydrogen, so hydrogen is here. I'm not even sure what I said just a moment ago. I was distracted, pardon me. So, hydrogen is depicted here as two atoms of, well, a molecule of two atoms of hydrogen that are bonded together. And here's another one, right? And oxygen, you can see with the red background, but you can see it's two atoms of oxygen. I'm a little distracted here, so pardon me if I misspoke. As you can see, we have hydrogen and oxygen. Hydrogen is depicted by white spheres, two of them, and there are two oxygen atoms here that make up of an oxygen molecule, right? So together they're combined to make water, right? So you have water, H2O. Probably should go to a different color, shouldn't I? Let's go to a different color for this one. H2O, right? Okay. So can you see there are two spheres here? These guys break up and make new partners to make water. So water is made up of hydrogen and oxygen atoms. The boiling point of water, so here's the big point, I think, of chapter 3, section 1, is that even though down here you have the same atoms as you do up here, right? How many atoms do you see here? 1, 2, 3, 4, 5, and 6. And here you've got 1, 2, 3, 4, 5, and 6. Okay, same atoms, but it turns out when they have their different geometric arrangements, they have very different properties. So let's go to the next table. This is on the top. I don't remember what page this is on, but it's in your textbook. And look what we have here. The boiling point of hydrogen gas is, wow, very cold. In other words, in order to get liquid hydrogen, you've got to be below that temperature because that's the boiling point. That's hydrogen gas. Oxygen gas, also very cold, right? Look at that. But in order to get water as a liquid, you do not have to get very cold. Matter of fact, water, where we live, right, the room I'm sitting in is probably, I'm guessing, 22 degrees Celsius. It's about room temperature. 20 to 25 degrees Celsius is about room temperature. And sure enough, if I had some H2O on my desk, it would likely be a liquid, right? So look at the difference in temperatures here. So these molecules, the point about this is molecules have very different properties Whoops, just a second here, pushed the wrong button. Depending on their composition, and I'm going to say connectedness. I think connectedness, depending on, we may later call that's connectedness. Sorry for my handwriting. Molecules have very different properties depending on their composition and connectedness, right? And that's the big take home of chapter 3, section 1. So Tro's using water as an example. Hydrogen, very cold, very low boiling point. Oxygen, very low boiling point. Put these guys together and boom, you get something very stable at room temperature. Okay? So state at room temperature, it's a gas at room temperature. This is a gas and this is a liquid at room temperature. And then also the flammability. This is explosive, and this is not very stable. So the point is that molecules have very different properties depending on their composition or connectedness. The boiling point of molecular hydrogen is minus 253 degrees Celsius. The boiling point of molecular oxygen is minus 183 degrees Celsius, and the boiling point of water is 100 degrees Celsius. Okay? So again, this matters to us because in order to understand materials, that's the study of chemistry, which I think is on page 3 or 5, we first need to understand the behavior of atoms and molecules. Okay, so look at this. This is also in your text, I think same page as that table. Hydrogen and oxygen, if you mix them together, depending on how you mix them, right, can be very different. So hydrogen and oxygen as a gas can blow up a balloon. Don't put a match into this, by the way. They can make up a balloon. So now it turns out that hydrogen and oxygen can have any ratio here, right? We can have only one of this oxygen molecule to as many of these hydrogen molecules as we wanted, or we could have 4 to 6, as it looks like we have here, 4 to 6. It could be any ratio at all. And do you remember the rule that we do you remember the law that we that is exemplified by this? This was the law of multiple proportions. No, it's not. The law of definite proportions, right? Because the law of definite proportions says that a compound has a fixed ratio, no matter where you get the compound from, a fixed ratio of the component elements. Okay, and sure enough, if I've got a teaspoon of water in here, it's going to be 2 atoms to 1 atom. If I've got a gallon, it's going to be 2 atoms of hydrogen to 1 atom of oxygen. If I've got an ocean, it's going to be 2 to 1, right? So compounds have a fixed ratio, and mixtures do not.